Hello everyone, it's a great pleasure to be hosting this illustrious panel for the second time. Today, like last year's OC3, I have with me Mark Russinovich, CTO of Azure, Mark Papermaster, CTO of AMD, Lavender, CTO of Intel, and Ian Buck, VP Hyperscale Computing at NVIDIA. Welcome everyone, much appreciated you joining us today. All four companies are trailblazers for confidential computing, and many of the things you're hearing about at OC3 have been invented and brought to market by them. Last year in the slot, these four gentlemen discussed about what is and what is not confidential computing. This year, our topic is confidential AI. What is it? What's the status quo? And what's ahead? So let's get started right away. Mark Russinovich, what is confidential AI?
Yeah, so confidential AI is simply confidential computing extended to AI scenarios. And AI is typically associated with GPUs and accelerators. And so that brings those into scope. As most people probably watching this know, we've brought to market confidential virtual machines. And at the end of last year, with NVIDIA, brought to market the first confidential GPUs with the H100 GPU. So that opens up the scenario where you can have AI workloads, training, inference, fine-tuning now fit into a confidential trust boundary that includes the compute on a CPU with a confidential virtual machine or container and an accelerator that is performing the AI operations.
That was crisp and precise. Then let's go to the use cases. I think that's certainly what's most exciting about this. Mark Papermaster, please tell us about what excites you most about the use cases of confidential AI.
Well, you have to back up first and just remember, why is it that we're all invested in confidential computing? It's really about making sure that you have full trust that your, key confidential data and information that's important in terms of processing around that data remains just that, confidential. So for AI, it turns out that it is a use case that really amplifies that need and that concern. Because when you look at the adoption of AI today, what is the biggest concern that really any business has? They say, look, I see great application for AI to improve our productivity because AI can put your data to work. You can train that data and you can run a myriad of inferencing applications. And, we all already have dozens of use cases where that speeds us up. But here's the rub. As you do that training, it's training on your data. You want to protect that data. Your data has to become confidential. And then the resulting weights that you have, that you run on inference, those weights are the result of your data. So they are also confidential and very material to your business. So, what the key use case is extending on what we already see confidential compute taking off on. So people are using it already today for sensitive financial data, healthcare data, very proprietary data, whatever their analysis is. But now, as everybody starts to run AI, you're seeing it is being a very, very strong use case. It starts today. I mean, the CPU is still very, very common for general inferencing tasks. So confidential compute on the cloud covers that. We've been very active in getting secure and encrypted capabilities out there and is an engine underneath. And that in turn, now as Mark talked about with H100, that in the Azure cluster, they work together. So we not only have this predominant use case, we're starting to already build out solutions for both CPU and CPU with AI accelerator. It's an exciting time for confidential computing.
It truly is, yeah. Anyone want to add use cases?
Yeah, this is Greg. Look, I think cybersecurity risk continues to increase. We read about it every day. The president, President Biden, issued some executive orders, particularly around safety for AI, responsible AI, security for AI. In fact, I made it my own T-shirt. I have it's a Venn diagram. There's security for AI and AI for security. So, it's an intersection of both of those things, right? So our security technologies are getting smarter using AI. We also need to protect, as everyone has just said, about the ability to basically, whether it's at the edge, which is scaling very rapidly, protect data and even your models and your parameters at the edge. But the privacy preserving capabilities are important as well here. And so I think, privacy rules and the requirements legislation is increasing. So I think everyone just has a heightened sense of the threat vectors that protect all, not just sensitive data and financial data, but increasingly all of your data, particularly about yourselves. And so I think we're all facing this and in this period of time. And as data becomes more distributed, the use cases are more distributed, the computing is more distributed, the storage and the transfer of the data to and from has got to be protected, as well as when you put it into the trusted execution environment. I think Mark gave a great example. He's got a nice YouTube video out about how using the H100s, you can secure the data that moves between the head node and the back end training environment. But again, back to the edge computing case, I think that's really where you've got a bit more of a Wild West scenario. You've really got to protect that data at the edge, because it's usually outside of any normal security perimeter. And the only real option is confidence computing. And just in the last year, we've seen a lot of increase in IDC and press coverage writing about confidence computing. I'm sure all of us are out talking to CIOs and CISOs with our respective businesses, and they're all asking this question: what is confidence computing? When is it going to be ready for widespread adoption? And all I can say is, when I talk to our salespeople, they're seeing more and more accounts asking about confidence computing and wanting confidence computing enabled hardware.
Yeah, and Greg, the edge will go right down to your end user devices as well, right?
Absolutely. Your PCs are the most vulnerable places where you need to protect that's where you have all your confidential data about yourself and your business and your personal life and your family. So I think all of us have been working on this for a number of years now. And so it's I think it's not quite ready to burst, but it's getting close.
So I'll mention another couple of use cases, Felix, that I think are really interesting, and several customers have actually lit up when I've suggested that confidential computing could handle the scenario where, for example, they've got speech that they want translated to text. And there's open source models that allow you to do that. And they've been traditionally running those models on premises because the speech that they're generating is so sensitive to their business that they're not quite comfortable in some cases of doing that kind of inference in a cloud. When I suggest that confidential computing can protect the prompts and responses for that kind of AI model, they get very excited because they all want to move to the cloud, and confidential computing could be the unblocker for them in that scenario. And then the other one I'll mention is, we talked about it a lot last time, is multi-party computations, which obviously a lot of computation now is AI, training AI models, for example. And if you can bring in data sets together, and we've talked about and shown this on CPUs previously, now we have the opportunity to show multi-party computation with confidential GPUs.
I'll add one more. We all heard about the giant language models getting even more giant. Just the sheer cost to train and to build these foundational models is massive. They represent a huge amount of value and investment, not just by the people who obviously work very hard on them, but also, of course, the companies that are being built is valued on their asset, their AI. Protect more and more. We hear about leaks of new kinds of models that get out. People are thinking about how can we make sure that we can take full advantage of our asset, our model, deploy it anywhere, but deploy it safely and securely, because it truly represents the value of what they've been working on for in some cases years, and the value of their entire for some of these companies, entire startup.
Okay. So to what extent and scale are you seeing confidential AI already being used in practice? What are the other signs you're seeing from your Intel perspective, Greg?
We have some technology we call open federated learning. It's open source for doing federated learning, where people are, they've already trained their models, but they're going to do shared inferencing. So they want to share data sets, but they don't want to disclose the original data that the models were trained on. And so they basically federate the learning activity by keeping the data private in their own private confidential computing environments, but they get a better fidelity, a better accuracy with the inferencing steps, having basically had access to the parameter data that was generated by the other training models. So I think it's really interesting that people are able to basically bring that together to get, let's say in medical science, there's been examples of this, where they do brain imaging, and then they aggregate the sort of the results to minimize the number of false positives they see, right? Because everybody has different brain imaging fidelity and accuracy. So I think, these kinds of applications in medical science, and again, because it's patient data, so you got to maintain confidentiality and privacy. So I think these kinds of examples are very clever and very creative, what people are doing using open source AI technology.
All right. So, Mark, you had a demo that was recently published on confidential AI. And in that demo, there was also some UX. So how will confidential AI look to the end user?
Yeah, well, I think it depends on what end user you're talking about, because I think most confidential AI will be invisible. It just like confidential computing, for the most part, will be invisible. It'll be systems that are authenticating each other with confidential computing attestations and deciding whether or not they trust each other enough to share sensitive data or keys. And it'll only be visible when something goes wrong and one party decides it can't trust another, or one system that decides it can't trust another, and then somebody needs to intervene to figure out why the trust was broken. I think that in the demo that I showed, it was interactive, and it was interactive just to demonstrate what's going on underneath the hood, typically in that kind of scenario. The demo, for those people that haven't seen it, is a confidential retrieval augmented generation demo, where somebody it has a web interface to a confidential service running in a confidential virtual machine. They are able to interact with a model that's hosted on a Hopper GPU, and they perform queries of this large language model. The large language model starts out with its pre-trained knowledge where it's unaware of confidential computing, and the user then verifies the attestations of the CVM and the confidential GPU, and then uploads a document that has information about confidential computing, which is representative of some very sensitive data. And that gets uploaded to the CVM, which then indexes it into a vector database. Then when the user asks the question again, the web interface in the CVM does retrieval augmented generation to give the LLM the additional information it was unfamiliar with, and then it provides response explaining what confidential computing is based on that document. And then I actually show a policy change where the user then goes and says, I only trust specific version of firmware on the GPU, and that firmware attestation doesn't comply. And so then they get a warning in the browser that the GPU is not trusted. Again, that typically would be invisible unless somebody had to manually intervene. But the scenario then, just from an end user perspective, might have like markers, like a lock on a browser URL to show that it's confidential. But again, a lot of these systems are just going to be autonomous systems, just part of operating independent of human interface.
What's your view on the maturity and the capability of what is available today? Ian, any thoughts on that?
Yeah, I think we're at a solid first step in confidential computing now with both CPUs and GPUs accelerators, which is really activating, you're seeing it, confidential AI. But it's still the beginning. We're not today. Obviously, we only have a limited footprint across the world's clouds, and I'll extend that to on-prem and edge. And I see that expanding in two ways. One, we have a wide variety of different AI models that want to be deployed. Some running on a single GPU, some running on a server with many GPUs, some that want to run even for inference across multiple servers or racks or even rows. And we need to scale this technology to support even larger models and do so in a way that remains secure, from not just within how the CPU talks to a GPU, but how GPUs talk to each other, how GPUs talk to networking, and across the entire data center. So the entire process can be secure, that we can execute and run these models in real time. Again, without performance compromise, because obviously they're very expensive models to run. And we can continue to work on the performance and capability of the technology. That's sort of step one on the sort of scale up of confidential AI. And then, of course, as this technology gets more pervasive into the rest of the different kinds of GPUs, CPUs, and servers around the world, we'll see a proliferation of the technology. We just need a little more time to get it into all the different sizes and capabilities of GPUs and servers and systems across the markets.
Let me just add to that, Ian. I totally agree with your comments. I just want to add in what I think will help that proliferation, and that is really come together on standards. We've just in that demo that Mark gave, I know the AMD and NVIDIA teams collaborated together just to help ensure it's the right CPU to GPU interlock. And we're all, even in the last time we were all together, we talked about authentication as key standard. But now there's an initiative that we're all working on, trusted I/O, and how to build confidential computing out through the networking. So I think it's exactly as you said. We are at the early innings here. We need to drive that proliferation outward from central compute complexes, and I think collaboration across the industry and standards will be key.
I totally agree. And I think as we establish more of the norm for confidential computing, those standards get more cemented, mature, and pervasive. And that's just going to be a journey that we're going to have to do together across everyone in the industry, not just the technology providers like ourselves, but also our customers and the regulatory and other aspects across different industries.
I'd like to add that it's still the CSPs that are kind of leading the charge here, being the early adopters. I mean, they build their own Linux kernels so they can take all the latest, code contributions from AMD, Intel, NVIDIA, integrate these into their runtime environments, bring it out as a managed service, for the customers. So sometimes you get the easy button to adopt it. You just allocate the confidential VM, drop your workload in there. You need an attestation mechanism typically, and that gives you, confidence and trust in that environment. So I think what's going to happen, I think this year, probably more like the sort of the second half of this year, we're going to see widespread adoption of confidential computing in the Linux distros. So we're going to see it in Ubuntu, we're going to see it in SUSE, we're going to see it in Red Hat. We both work, we work with AMD, we work with VMware together to get the adopted into the hypervisor environments, trusted containers in the Kubernetes environment. So it's just proliferating up through the software stack and the software infrastructure that the DevOps people that are running on-prem or in the cloud or at the edge are going to start using more and more. We have KVM enabled with trusted VMs. And so I think that's the next step. That's really going to drive the enterprise adoption and the enterprise level of confidence when the mainstream Linux vendors have it as a supported feature of their distros.
Yeah, absolutely. Okay, let's talk about a less technical topic. How does the changing regulatory environment impact the need and urgency for something like confidential AI? Any thought on that? Maybe you again, Greg?
Yeah, I think, I mentioned in my earlier remarks about sort of these executive orders that have come down from the White House, first regarding general cybersecurity, zero trust, for the federal government, certainly, and their suppliers, which are all of us. And so I think, those kinds of things are certainly getting a lot of attention, and it takes time, but it takes time for this technology to get embedded into those IT environments because the IT people may not be up to speed and capable of managing these types of systems. So I think, but those orders kind of focus attention. They result in procurement orders coming out from the federal government to all of us to basically bring this technology forward, accelerate capabilities that we get with confidential computing. And as I said, privacy and safety and responsible AI are going to be big forcing functions for this as the government adopts AI technologies from the industry. And then, of course, there's going to be lots of fraud that people are going to use AI for mal purposes. And we need to protect against that. So I think we all have a social, ethical, and professional responsibility offer these technologies widely across the industry as fast as possible so that we can bring those levels of extra security, extra zero trust protection, into these environments, not just the government, but our hospitals, our schools, the entire industry. So we'll probably 2 years from now, we'll be looking back, having looked at this recording, and we'll see, all that's now played out, because I think the government does have the power of forcing the industry to get focused around these things.
Greg, I agree, but I think we can move more quickly than the government, because you and I have been involved in that area, and I think actually the kind of collaborative work that we have going, getting these efforts aligned, getting, as you said, getting it upstreamed, is a lengthy process in itself. So what I love to see is that by the time the regulations are done, we're already well advanced on the journey as an industry. Confidential computing.
I think the industry will be there. I'm not sure the systems integrators that the government relies on to bring the technology into their environments will be ready.
I'll add one more thing about the way that software and supply chain, which the White House is very focused on supply chain, the government, intersects with this, AI specifically. If we talk about software bill of materials, for example, I think where all of us see things going in terms of transparency of our supply chain is having a confidential ledgers, tamper-proof evidence that's attested with a confidential environment of the artifacts that go into that bill of materials in such a way that it's irrefutable that a particular artifact contributed to something that has access to some data. And nowhere is that more important than for AI models that get trained on data, where you want to understand the provenance of the data, be able to know a particular piece of data was involved in the training because it might be poison data, it might be data that got swept up in a massive data gathering that shouldn't be there. And you want to be able to have that evidence preserved in a way that you can go and say, this model has this data that fed into it.
Yeah, I think this is a super important point. Everything tying together with modernization, software bill of materials, immutable logs. I think that's really what's ahead. So it's been an amazing and insightful discussion. Thank you so much, everyone. To round this up, I have a final question for you. Will AI be the killer app for confidential computing? And will it maybe even become the standard for AI? Will it be considered careless if you are sharing data with a non-confidential AI? And if yes, when?
It's a leading question.
Indeed.
All right. I can start. I think it's absolutely going to be a default. I mean, you look at all the things each of us talked about and how we're working to make this easier to deploy, make this seamless. So it's just, in my mind, it's an eventuality. And I do agree with Greg's comment. I do think the regulatory forcing functions are coming, but I think we may get there ahead of it.
Let me add a perspective. And I agree, last year we talked about confidential AI becoming ubiquitous, an opportunity like our web browsing, just to it always be on. And we just enjoy it and we know it's safe. There's a market. I do believe that confidential AI will be the killer app for confidential computing, because I believe confidential AI is going to open up a new opportunity. And we're really just at the beginning. If you hear about AI today, you often hear about many of the same names that we've all seen in the news, or startups that are given the names of a unicorn. And that's largely because building a modern AI is a huge effort. It requires huge amounts of data. It requires expertise in software. It requires the infrastructure to run all that training workloads. And then you have to have access to a customer platform and the number of customers to monetize and make it available. And the output of that is a foundational model, which is your own, but it's difficult to deploy and exercise elsewhere, let alone specialize it further. If you insert confidential computing into that mix, every part of that process now can be democratized, separated, made available to any other player to offer a service or capability to another. The data can be protected. The software that is run is separate from the infrastructure it's run on. Could be even separate from the customer platform that's being provided. And foundation models can be protected or specialized with techniques like LoRa in separate confidential computing enclaves. If that happens, we've just opened up an economy of people with data, AI software, foundation models, infrastructures, and specialization that allows new business models to happen, allows not just the people that can afford to build the whole thing end to end, but an entire economy and built upon free market and access to all sorts of different kinds of AI. That's only possible if all these parties can trust each other, can know that their IP, their information, their life's work is protected, and confidential computing does that. So I am obviously on like step one of that marathon journey. But as confidential computing becomes pervasive, I totally believe that it will unlock a new marketplace for computing, for AI, because everyone can trust each other and operate independently and know that their work is secure, and just continue to allow AI to take off like a rocket ship.
Jose, it's a new category, and I think we have to sort of think of it that way. It's like AI at the PC. That's kind of a new category, right? And so I think, and these government regulations or executive orders, they're just ways to accelerate, the creation of this category, the innovation of the technology. Those of us have been doing this for a few years. We keep waiting. What's the singular event that kind of is the kicker? And I really think it's AI is the kicker. That's good, because I think it's a match, sort of a match that fits well together, hand in glove, because confidential computing is at the right time at the right place, just as AI is exploding. And we know there's lots of, again, ethical and responsible AI issues that we have to address as an industry. And confidential computing gives you the core foundation on which to build that larger system of responsible and safe AI.
I'll just pile on here. I also believe that AI is the killer app for confidential computing. And I agree with Ian's vision for the marketplace opportunity, the economic opportunity it's going to create. But I think it's, for me, also a killer application, because if you take a look at the base cases for confidential AI, which are the one that I mentioned earlier, inference, and then training, they're very encapsulated, well-defined workloads. Unlike when you just say confidential computing for IT workloads and data is everywhere and it's harder to understand the flows and how to protect things appropriately. When I talk about protecting a prompt and a response that a model is going to process, it's very clear what I have to protect. And so that is a very tractable architecture to go design first and then build on from there. And that one immediately provides huge value, like I mentioned, and excitement, I think, from the customers that I've talked to.
Totally. Fantastic. Thank you all. Until next time.